right, so we're just going to try this out. I was just going to look over the 3.1 homework. So in 3.1, we are talking about functions. So for this first question, it's just asking us to determine which of the following represent y as a function of x. So just remember, when you have a function, that means that every x value you plug in, you can only get one y value back out. So if you look at this first one, if you plug in a 2, you actually get two answers, right? You get this one and this one. That's just, for example, there's a bunch of them. This one's bad. A quick way to test that is to do the vertical line test. If you draw a vertical line and it hits it more than once, it's no good. So that one's no good. Look at this one. Oh, that vertical line just hit it 3 times. So that one's no good. That one looks good. That's a straight line. So that is definitely a function. So we're good to go there. So I'm going to go ahead and click that one. That one's good. Look at this next one. If I were to draw vertical lines, it's not going to hit it more than once. So that one's going to be good. This next one kind of looks like a sine curve. That one's good. Horizontal line, he's good. So again, imagine drawing a vertical line. If it hits it more than once, it's no good. So those first two are no good. Last ones are cool. All right, let's look at question number 2. So question number 2 is the exact same thing. So we're just going to skip over that. So question number 3 wants us to do the same thing, but this time it's given in chart form. So again, remember, to be a function, every x in the domain is related to exactly one y value. Okay, so you can't get more than one, and you can't have just something missing. So if you look at the first one, let's see, 4 goes to 3, 7 goes to 8, 13 goes to 8. Looks good. In the second one, 4 goes to 3, 7 goes 2 places. 7 goes to 8, and 7 goes to 14. So that's no good. You see, every x has to go to exactly one y value. And in the last one, let's see, 4 goes to 3, 7 goes to 8, 13 goes to 14. We're good. Notice in that first one, both the 7 and the 13 went to 8. That's fine. They're 2 different values. So if you were to kind of look at those on a graph, I go over 7, I go up 8. This is not very accurate, and then if I go over 13, I also go up 8. But notice that's fine. That doesn't mess up our vertical. It would mess up the horizontal line test, but that's a whole different story. So these represent y as a function of x. So the first 2 are cool. Or sorry, first and last one are cool. 8.4, same type of question. All right. So now what it's looking at, it's asking us about being a one-to-one function. So remember, to be a function, every x has to have exactly one y. To be one-to-one, it has to work the other way as well. Every y is only related to one x. So if you think about this, the actual definition for one-to-one is that if 2 y values are the same, then their x values also have to be the same. So that may seem a little obvious, or maybe not so much, but it's saying if 2 y values are the same, then their x values had to be the same. In function notation, you would say if f of a equals f of b, well then a has to equal b. So let's look at that first one. Let's just say that f of a was equal to f of b. What would that mean? That would mean that a minus 4 over 5a minus 5 is equal to b minus 4 over 5b minus 5. So the idea is, can you think, could the a and the b be different here and still give you the same answer? So that's kind of the question here. And looking at this, I kind of want to do long division or graph it. We know that the second one's going to be okay because that's a line. The last one is actually going to be bad. But in this one, let's see, we've got a horizontal asymptote at 1/5. I don't see any way that a different A and B could give me the same answer. And I don't want to go, we can do all the algebra here and solve for A. But I don't see an issue with that one. The main places that we see problems are with things like parabolas, because a parabola looks like this. So notice that this y value has two different x's it came from. That's no good. So if you look at this last one, let's say that h, it's an h, right? H of A is equal to h of B. That would mean that a squared minus 4 is equal to b squared minus 4. Now notice that means a squared equals b squared. So if you were going to actually solve this for A to try to determine if A is equal to B, remember what you have to do when you take the square root of both sides. You have to put a plus or minus on it. So this does not say that A equals B. You see that? It says A is plus or minus B. So this one is no good. No good at all. Absolute values can also cause problems because the absolute value of 4, for example, is equal to the absolute value of -4, but 4 is not the same thing as -4. So you see the way this is worded, if you get the same answer, it had to come from the same value you plugged in. So absolute values are often, it doesn't mean they're always bad, but they're often bad. So we're going to say, determine if each one, I'm going to say he is good. I'm going to say he's definitely good. And I'm going to say he is not good. Yay. All right, so now this is the same question. Actually, yeah, so we'll skip that one. So this one looks like a big mess, but really all we're doing here is plugging something in. They just want me to plug in this value. Oops. They want me to plug this in for x. So you see the notation here. This is f of x. This one says f of, and there's a number there. So all they want me to do is plug that number in for every time I see an x. So I'm just going to rewrite it. Now I'm just going to use parentheses instead of an x. And then inside those parentheses, I'm going to put what they put in the parentheses. 1 plus the square root of 2, 1 plus the square root of 2, 1 plus the square root of 2. Now, of course, we have to simplify this. We can't possibly leave it like this. We have to cube this first one. That's not going to be the funnest thing in the world, but let's cube that real quick. So we got 1 plus the square root of 2 times 1 plus the square root of 2 times 1 plus the square root of 2. So I'm just going to multiply the first two together. So 1 times 1 is 1, plus 2 square roots of 2. That's the outer and the inner. And then for the last ones, notice that's the square root of 2 squared, so that's really just 2. So now what we actually have is 3 plus 2 square root of 2 times 1 plus the square root of 2. So let's FOIL this one. 3 times 1 is 3. For the outer, I'm going to get 3 square roots of 2. And for the inner, I'm going to get 2 square roots of 2. And for the last, notice I'm going to get 2 times 2. We've got the 2 there, but then when we multiply the square roots of 2 together, we get 2 back. So this cube is actually, let's see, 2 times 2 is 4 plus 3 is 7 plus 5 square root of 2. So I'm just cubing that guy. So now I'm going to come in, I'm just going to erase here. Let's erase that real quick. And see what we have now. So I have 4 times, we just cubed that, 7 plus 5 square root of 2, plus 4 times the square, and we squared that, actually it was underneath there. It was 3 plus 2 square roots of 2. So square the first one, you get 1, multiply and double, square the last one. All right. And then we're going to have 4 times 1 plus the square root of 2 plus 3. All right, so now let's distribute all those 4s. So I have 28 plus 20 square roots of 2 plus 12 plus 8 square roots of 2 plus 4 plus 4 square roots of 2, and then plus a 3 there at the end. So let's put our numbers together. So 28 plus 12 is 40, plus 7, that's 47. And then let's put our square roots of 2 together. All right, so we got 20 plus 8 is 28 plus 4 is 32, I hope. So 28 and 12 gave me 40, there's 7. And then we got 28, 20, 30, 31, 32. All right, so I'm going to go with this and hope that's correct. So we've got 47 plus 32 square roots of 2. So 47 plus 32 square roots of 2. So let's try that. So 47 plus square root, how many of them were there? 47 plus 32 square roots of 2. That looks good. Yay, we did it. All right, so just be very, very careful with that one. Concept itself, I don't think is that bad. Just whatever's in parentheses, you're going to plug in for the x. Just make sure you use parentheses there. Be very careful. So this is the same type of question, just a different function. So they want you to plug in a 0. You'd get a -8. They want you to plug in a 2. You'd get 2 times 2 is 4. Times 4 is 16. Plus 6 is 2 minus 8, etc. With the -2, just be careful that you use parentheses. Notice that -2 squared is going to be a +4. But then there in the middle, you'll have -6. The x plus 1 will be kind of like that last one we did. You're going to have to FOIL out this x squared here at the beginning. So just be very careful on that one, but it's the same type as the last one, except now these last two, you'll have x's in your answer, of course. But just make sure you use parentheses there. Be very careful. So this is the same type of question. Again, notice this is a negative. Just be really careful, you guys. You know what? Just for the heck of it, I'm going to do this one. You just need to be very careful. But what they want me to do is in a -1 everywhere I see, in this case, a t. So notice I'm just replacing the t with question marks, or sorry, with parentheses. And then inside those parentheses, I'm putting whatever they want me to put in. All right, so notice this is -1 squared, which makes it a +1. This is 4 times -1, which makes it a -4. So I get 1 minus 4 plus 2, which is -3 plus 2, which is -1. So just be very, very careful here. Let's put that in. So we're going to get a -1 here. Apologize. All right, let's look at question number 10. So this one's asking me about increasing and decreasing. And notice it says intervals. So we're going to have to put our answer in interval notation. So remember, that's with your parentheses and your square brackets. But first, I got to figure out where this thing is increasing and where it's decreasing. So let's look at the increasing. We'll put that in blue. Increasing means that from left to right, the function is increasing. You always look from left to right. So notice if I start looking at this, it's going up here. Up, 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 till it gets there, then it stops. Now it's decreasing. How about if we make decreasing orange? That's kind of an orange. Decreasing, stop. And now we're back to increasing again. So it's increasing in the blue and it's decreasing in the, I guess, brown. But now I do need to kind of nail down where exactly that happened. So let me just erase here. So it's actually increasing. Let's see. It started increasing, well, forever back, right? This thing has been been increasing this whole time until it got to, doesn't that look like negative 2.5? It looks like it's right in between. Now, at that particular point right there, it's not increasing or decreasing. So make sure you use a parentheses. You don't want to actually include that maximum. It's actually called a maximum, a relative maximum. You don't want to actually include that in your answer. And then it starts increasing again here at 0. So I'm just going to use a union symbol. Now notice it's not actually including the 0, because technically at 0 it's not doing anything. It's kind of come to a halt down here. It's like, oh, stop for a second, now I'm going to go back up. So you can't include that actual point right there. So again, with parentheses, not brackets, and this goes forever. So that's going up to infinity. Now the decreasing is just here on this interval. Remember where we had the kind of brownish color. So on the left, it starts at negative 2.5 and goes up to 0. Now again, notice the parentheses I used everywhere. That's because you're not actually including the actual negative 2.5 or the actual 0, because at those spots, this is actually called a relative maximum, and this is called a relative minimum. It's not actually doing anything right there, so just be careful. All right, so let's put this in, and let's see, we should have the union symbol. I wonder if it's in here. There it is, intervals, you see that? I'm going to want parentheses, and so remember we had negative infinity on the left. Now I'm just going to use the right arrow key to move over, and we were going up to negative 2.5. Now I'm going to use the union symbol, see it right there? And then we had more parentheses, so remember it went from 0. I used the right arrow to move over, and to infinity. So there's my first one. So now for the second one, again, I'm just going to push in this little yellow box. And then it pulls up. I'm going to go to intervals, and I'm going to pick those parentheses again, because remember we don't have any brackets on ours. On the left it was negative 2.5. Oops. Doesn't say 2.5, 2.5. And then I'm just using the right arrow key to get over, and that goes up to 0. Let me make sure I didn't mess up that other negative 2.5. Negative 2.5, negative 2.5. All right. Bam, we're awesome. Okay, so let's look at the next one. Same question. So again, just be careful, and you can just kind of, that's definitely at negative 3 where that part's happening. And then this one's at negative 0.5, 0.5. So just be careful there. Same question again. And all right, this one's a piecewise function. They just want me to figure out what each of the pieces are. So notice a piecewise function, what it does is it breaks it up. So this first one says when x is between negative 6 and negative 2, I want you to do this. All right, well, what are we talking about? So from negative 6 to negative 2, they're talking about this line right here. Oops. They're talking about that line. So what I want to do is put the equation for that line right here in the red. Okay, so how do I find the equation of a line? Well, we can, here, let me erase where I wrote on it so we can see it better. We just need to figure out what the slope is, and then we can grab a point, right? So we can find the equation. So remember, we've got this nice y minus y1 equals m times x minus x1. So we can just use that. So if you look on, let's see, the slope looks like we went up. Let's see, we went from negative 1 to 3, so we went up 4. You see, from here up to here, that was 1, 2, 3, 4. So up 4 and over, let's see, from negative 6 to negative 2. Oh, and over 4, right? 1, 2, 3, 4. So this was up and over. So there's my slope. X minus, just pick one of the points. I'm going to pick that negative 2, 3 point. So the x was negative 2, and my y was 3. So I just picked this point. So again, that point was at negative 2, 3, and then I have a slope of 1 here. So y is equal to x plus 2. Notice this is just a 1. So that's x plus 2, and then I'm moving the 3 over. So really the equation is x plus 5. So that's the first one. All right, now let's look at what they want me to do for the second little bit here. So for the second bit, notice this is from -2 to 3. So from -2 up to 3, what am I doing? Oh, I'm doing that line right there. That's a horizontal line. And where is it? It's at 2. So this is the equation y equals 2. So that wasn't very exciting. There's a 2 right there. All right, and so now for this last one, let me erase, oops, sorry. Let me erase all my writing over here. So let's look at this last one. We'll do him in green. Now, notice from the picture, you can tell it goes from -3 to, well, I guess it stops there at 6. So here's my -3, or sorry, 3 up to 6. And this is going to be another equation of a line. So I want to try to fill this equation in, and then I'll solve for y, just like we did back in 2.2, I think. So first we might want to try to figure out the slope. So I'm just going to write this point down. Let's see, that's the point 3, 1. And then this bottom one is the point 6, -6. All right, so for my slope, and so I'm going to pick the first one. So y minus 1 equals m times x minus 3. So let's just put the m in there. So my rise was 7, because you're going from -6 up to 1. So that's a rise of 7, and you can count as well. This is, oh, actually, that doesn't look like it's at 6, -6, does it? It's almost off of the screen. You think that's 6.5? This is no good. Is there a better? I wonder if this point, that point looks like it's right on the line. Let's try that one. Let's try 5, -4. It appears to be there. So I'm going to try that, 5, -4. And let's see what we get. So for rising, we went from -4 up to 1. So that was a rise of 5. And then we went left 2. So that's a -2. I think that looks like it's on the line. So let's see what happens. We'll get y minus 1 equals -5 halves x. Notice that's going to be plus 15 halves. Now I'm going to have to add the 1 to both sides. So notice I'm going to add it on as a 2/2 so that I get a common denominator. So I'm going to have y equals -5 halves x plus 17 halves. And I'm a little worried about that one because it's not real obvious where my point is supposed to be. So let me just write this down real quick. So we had x plus 5 for the first one, 2 for the second one, and -5 halves x plus 17 halves for that last one. So I just want to see, I wonder if I were to zoom in a little bit, if it would be helpful. No, it doesn't really help anything. All right, well, let's try it out. So for this one, we've got x plus 5. Or was that x plus 3? Darn it. I hope I didn't write that down wrong. And that one was a 2. And then for this one, we guessed that this was crossing at the line here, 5, -4. So we went with -5 halves x plus 17 halves. So let's see what happens. And, oh, we did it, you guys. Nice. All right, so again, my worry there was I just wasn't sure if this point right here in green was exactly on the line, but I guess go with what it looks like. So we had that one. I didn't point out, notice that our first line had solid dots, so that's why both of these had an equals on them. See, less than or equal. Our middle one, notice, has open on the left. It doesn't have a line. Solid on the right, and you see the line underneath. And then the last one on the left was open, And on the right, which you really can't tell, but that is solid. So I just wanted to point that out. If it's got that line under it, it's going to be a solid dot, which is the equivalent of a bracket if you're doing interval notation. Whereas if it's like this, it's going to be open. So in interval notation, that would be a parentheses. Okay. So just wanted to point that out. So there's your homework in a nutshell. And we'll see if this recorded. Hopefully it did. Oh, you don't hear that. Perfect timing.